Welcome you all. I am Dr. Arun. Just for a quick feedback, I am asking your class representative. Ashik, please respond in the WhatsApp group if you are able to hear me. Is my voice clear considerably to a considerable extent? Okay, I got a good feedback from your somebody also started chatting that it is clear. So then in that case we can begin. So control systems 1. This is the subject which we are going to learn in this semester together. So I have done my PhD in the topic of control systems at IIT Kharagpur, and I was also an MTech student here from 2009 to 11, and I am also very happy to say that I was a gold medalist during that time. This is one of my favorite subjects, and that's why I have chosen the specialization, instrumentation and control systems, for my MTech. So what I will do is I concentrate more on conceptual things, and I expect students to solve problems for them on their own. So I will stimulate a lot of thinking. I will share a lot of good interesting videos, and if somebody is interested in doing some assignments in MATLAB, we will make a possibility for it. Those who have their laptop and MATLAB installed, they can approach me through email, and I will create things for them. So now moving into the subject, control systems. First term what we hear is system. I think everybody knows what a system is. System is collection of objects to do a specific task or purpose. So a system has input or excitation, and it gives an output or response. A system can be a collection of various subsystems. So we will be seeing what the subsystems and why we call it as overall system in the coming slides. Can anybody give an example of a system? Maybe Manthan Pandey, can you give an example of a system? So are you able to unmute yourself, Manthan Pandey?
A system is a collection of some digital capacitor and some takes some input and some output.
Yeah. He gave an example of an electrical system, electrical circuit. So let us see some popular ones. So the first example is an electrical motor, which is an electromechanical system where input is electrical energy, that is voltage, and output is mechanical energy, that is either torque or rotation. The second example is air conditioner system. Output or the desired purpose here in this case is the temperature, the ambient temperature, and input is again electrical energy. Now the third example, which is the popular one, right now because the virus is taking its toll on human beings. So how we see it as a biological system is input in this case is drug administration and output is how effectively the drug is eliminating that virus. So control systems, that this COVID-19 situation can be seen in the context of control systems also. The fourth example is, which is a buzzing topic these days, electric vehicles. Their input once again can be either acceleration, deceleration. What they mean is the pedal, which they are saying is here in this context, what input is the pedal which you are pressing on the accelerator, and output is the vehicle displacement. So I request participants to chat in the chat box so that I'll get some feedback, because this is not a conventional classroom where I am able to see everybody. So if you are to this vehicle concept, then I will go to the next slide. You may type proceed if you are following. Okay, thank you. So next is the classification of systems. So systems can be classified as, or systems are classified as linear and non-linear, static and dynamic, time variant and time invariant, causal and non-causal systems. So coming to the first classification, all real-time systems are non-linear. So, but they can be approximated as linear systems at around an operating point, which I will be sharing an interesting video of it, how non-linear systems are linearized and what are the advantages, why we are linearizing and all. So inherently some systems are linear. Say for example, your simple R network, resistor element. If a voltage is applied across the resistor, current flows through it, that resistor can be a bulb. So resistive load, example of resistive load is bulb. So voltage V is applied across the resistor and current flows through the resistor. So the fundamental equation governing this particular system is V is equal to IR, or I is V by R. So this is an example of linear system. So can anybody give an example of non-linear system, where the relationship between input and output variables is non-linear? So I will give the example for a non-linear system. Diode is an example of non-linear system. The voltage and current are related by a exponential term, not a linear relationship, where it's not a linear relationship of the form y is equal to mx. So linear systems satisfy the principle of superposition and homogeneity. Non-linear systems do not satisfy the principle of superposition and homogeneity. Second classification is simple but straightforward, static and dynamic system. The resistor is an example of static system. Example of a dynamic system is RL or RLC or RC. Third classification is time variant and time invariant system. The system is said to be time invariant if it produces the same output irrespective of what time it is applied. Suppose a system when an input is applied at some time, this is the input. If the system gives some response at that time, and if the input is shifted in time, then the system should also give same response. Time shifting of the input doesn't change the behavior or response of the system. So, example of time invariant system is once again your RL network. Example of time variant system is a rocket carrying fuel because mass of the rocket will change as the fuel gets exhausted. So, it is an example of time variant system. And fourth classification is causal and non-causal system. A system is said to be causal if its output depends upon the present input and past inputs. It is non-causal if its output depends on the future inputs. So, example of causal system is once again your order network. Most of the physical systems are causal systems. Example of non-causal system is examples are weather forecasting and missile guidance. To explain a little bit about non-causality, suppose there is a plane and we have to hit this plane from this particular station. So, we will only be hitting the plane correctly if we can predict its movement. Suppose we need to know approximately with what velocity it is moving in what direction. So, we need to know about its behavior. So, some kind of prediction is required. So, you are predicting and then only you will be able to hit it correctly. So, this is an example of non-causal system. So, I request students to give physical examples of physical systems in real world for each of the classified systems. Not examples which I give. So, you spend some time and I expect at least your class answer 60, so I should at least get very good examples, at least say 10 new examples. So, now coming to control systems. As the name indicates, control system, it is a system which controls other systems. So, it directs input to other plant or systems to achieve a desired purpose. System by itself may not be able to achieve that purpose. So, that is why we use the control system. So, the block diagram shown here is an example of open loop control system. So, if we take an example of air-conditioned room, output is the actual temperature and input is the desired temperature. You want to maintain the temperature of the room at particular temperature. That is your desired input. So, if you will see, you will observe. If you are in that room, you will observe what is the actual temperature. If the temperature is more than, say, if your desired temperature is 30 degrees, if the temperature is 32 degrees, then you will on and off the air conditioner. You will on the air conditioner switch. If the temperature is 28 degrees, you will off the switch. So this is manual or open loop control. You have to see every time and you will do it. So in different books, different terminology are used. The same diagram is used in a different terminology. That is, The input is called set value or set point. This is called control element and this is called correction element, and plant is also called a process. Output is called required value. So another example of open loop system is you are tracking and you are adjusting the rotation of an aerial dish to track or to receive the satellite signal. So in this case, what is the input is like input of the required rotation, that is the input, like in what direction our aerial dish should be oriented. So to achieve this purpose, you will give a command and actually you will be using an amplifier to drive the motor, which is the correction element in this case. So amplifier in the sense some mechanism where you are using, like you are turning some knob or something, or you are turning some steering, etc. You are turning a mechanical mechanism. So that is the control element, and that gives a command to the motor drive, and motor drive is the correction element. The motor is the correction element. Process is the gearbox and aerial dish. So far so good. Then what is the problem of this? So you have a desired reference. You will design a controller or you will do it for a particular desired reference. You will use a particular controller for a particular desired reference. You will use a particular controller and the output is a desired state. Okay, that's fine. But the problem is whenever there is a disturbance in your plant or system or process that has to be controlled, then this setting may not work. This setting will not work. So that is the main reason why we have to continuously monitor the output, compare it with the desired reference, and then if you design a controller in that situation, that will also be able to eliminate the disturbance. This is the main reason why we use feedback. There are other advantages and disadvantages of using feedback, but the main reason why we use a closed loop or a feedback is to reject the disturbances successfully. So the solution is just to continuously see where you are and continuously measure the output using a sensor and compare it with the desired output response, and the error signal is going to the controller, and controller will give the command to the actuator, and actuator gives the actual input to the process. So typically if your controller is a computer, which is the brain of your system, then the computer cannot drive any motor or anything. So computer can give an electronic signal to an actuator like amplifier or anything, and amplifier actually gives the command to the process at the required voltage level. Say for example, you are controlling a level of liquid in a tank, then your controller cannot drive the pump. So controller will give you an electronic signal to the amplifier, and the power amplifier will give the appropriate input, that is voltage, to the motor, which is motor will once again will be opening or closing the valve. So these things, like in textbooks, what they do is, this is the general block diagram. The actuator and process, they are all clubbed. You will come to know why they are clubbed and what is the advantage of clubbing them in the future lectures. So Actually, when you draw a block diagram, everything should be drawn properly, like everything should be taken into account and then clubbed for convenience of design, which we will be learning in future classes. So this block diagram can be further expanded, like what is this actuator, which is power amplifier or something, or then what is the final control element. Final control element is when two-level control system is valve, but motor is an intermediate subsystem. So now this whole thing can be called as a system, and individual controller is a subsystem, actuator is a subsystem, process is a subsystem, and sensor is also a subsystem. So this is the typical block diagram for a temperature control system. Actual temperature is compared with the desired temperature, and if the temperature is more than the desired temperature, then air condition will be switched on. That is, this controller gives command to the air conditioner. So it will exactly switch off when the temperature is below the desired temperature. Like this, it will arrive at a suitable point, arrive at the bandwidth of around the desired temperature. It will settle down around the desired temperature. So if somebody enters, then automatically AC has to be turned on, air conditioner has to be turned on. If somebody leaves, then it has to be appropriately switched on. So another example is a vehicle steering mechanism. The output of this particular example is the heading along the road. How you are tracking the road, or how you are traveling on the road. So if a path is charted down for you, you will continuously observe, you will see on the road whether you are driving on the correct path or not. So the controller in this case is, the sensor is observation by the eyes of the driver, and the controller is the brain. It is taking the decision, yes, I am traveling on the right direction, right path. If I am deviating from the path, then I will steer the vehicle. So the actuator in this case is the driver's hand, and the correction element is the steering wheel. So finally, if you do the steering properly, then the vehicle will take the path which it is intended to take. So if it was an open loop system, then if you have designed a predetermined path, if there is some bump or somebody is coming in your path, then you will hit them or you will lose the direction. If there is a disturbance, open loop system will not work. So a feedback system will effectively work, and it is a common thing that in this physical example we understand that it is always a negative feedback, not a positive feedback. So if it is a positive feedback, you will never able to achieve the desired purpose. So here are a few tricky questions. Actually, here 3 bullet points are given, but it is only one question, one tricky question. That is, all closed loop. If somebody asks you, are all the closed loop systems automatic? So if you say yes, then it is not the case, because in the previous example which I showed, this is also a closed loop system where human being is present in the loop. So by automation we mean that human involvement is not there. So all closed loop systems will definitely have feedback for store. And in the similar context, another question can be twisted and asked like open loop systems are manual or not automatic. So once again, it is depends upon the perspective of the questioner and what is intended to ask. But in general, open loop systems are manual and they will not be able to they may not be manual, but they will not be able to reject the output disturbances anywhere effectively. Yes, our final goal is to reduce the human intervention and automate everything. But you cannot eliminate a human being. His role will be limited and we are trying to minimize it. So for example, for complex and boring tasks of packaging and some dangerous hazardous tasks like plucking deactivating some kind of bombs and all. So in such situations, this automation is going to be very useful. That is our ultimate goal. So the activity of the assignment which I suggested with examples of open loop and closed loop systems and give advantages and disadvantages of open loop and closed loop systems. You can see interesting videos. This first link is the videos given by MATLAB. They also give a physical example of control system, open loop system and closed loop system. And the second link is the control system contest, winner of the control system video contest conducted in 2014. If you go to this particular website, this is IEEE cases, which is nothing but control system society. So in this link, you will see variety of interesting videos which will help you which will motivate you to learn this subject. So with this, this finishes your lecture 1. I hope, because I am not able to see everybody or something, it is almost one-way traffic. I hope people have understood something and the same PPT with voiceover that's uploaded in your LMS, WebEx Edu server. I request students to go through it. And I have also recorded this particular session in this platform and it is already 28 minutes recording is going on. So I will share this recording with you. Right now I am stopping the recording, but I can take questions if you have any. So any questions? Just now I have seen there are 71 attendees. So if I say everybody will be keeping silent, the recording is still going on. So I will choose somebody. Ritvik, are you from B batch or A batch?
query, sir.
Please, all of you, because I have an option of unmuting all. If I unmute all, but if you mute all, then you are not able to turn on your microphone. So what I request is, all of you mute your microphones on your own. And the person whom I ask, they will unmute and they will respond. All of you, please mute your microphones on your own. So this is also an indication that people have kept the window open and they are doing their own, they are not using their microphone. So, speaking mute yourself. So Manohar Bhattu is not attentive. They just kept the screen open. Somebody Royal. Joshi, please mute your microphone. So I manually individual participants. It is going to be difficult for me to manually mute who have not kept. So that clearly shows that those people are not attentive and they have kept the kept the session open. They are doing their own task.
Sir, I have a query, sir.
Yes, please. It would be better if you can turn on your video also.
Video.
Okay, go ahead. We will not just ask the question. It's okay.
Is that you said that open is a free program, program with what to do for. So isn't it always automatic? Like it's not. It doesn't take care of the disturbance or any other noise. So it should be an automatic system, you know.
Which one?
An open loop system.
Open loop system, that's the trickiest part here. That's why I said it is a tricky question. So, any system you call it automatic if it does things automatically for you. Right? It should automatically mean it should work irrespective of if there is any change in the output, it should automatically correct itself. But will the open loop system be able to do it?
So are we taking the section factor? Like automatic by automatically mean that it should adjust with the tool also.
Sorry, can you?
Like sir, by automatic doesn't it mean that it is a pre-programmed system and it will take some input and give output? Irrespective of the disturbance, like if disturbance is coming, it might not correct that disturbance, but it is giving some output from what to the program it has been given.
Yeah. In that context, yes, that is why I said it is a tricky question. It depends upon the perspective and the context. So there is no clear-cut answer, but the question which has a clear-cut answer is why feedback? Why do we require feedback? Because if you are not constantly measuring the output, then you are not able to take a corrective action. That is why we require feedback. That is why we are going to process. That is a clear-cut question. But if somebody twists and turns, it can be manipulated and it is only perspective. According to your opinion, if it is pre-programmed, then yes, it is automatic. See, for example, packaging or bottle filling system. It is automatic, right? In that case, very rarely some cat or something will come and push the bottle which is there in the thing. But human intervention is there in the system also. There is somebody who is switching on it, who is supervising it. He is not doing the entire activity, but he will be supervising the bottle filling or liquid filling or water filling plant, automatic water filling plant and packaging. I hope to some extent I have cleared your question or doubt. Anjan, please respond.
Yes, sir. Understood.
Yeah, that's why I said it's a tricky question. And those may not be asked. And I wanted people to think about it, that's all. So, we are hoping that students will return to campus, say in November or December. If end-term happens physically like a conventional end-term exam, then there is no problem of grading. But if it is something, if the situation demands and you people don't return to campus because of the situation, then we are planning to have an individual. Otherwise, if it is through assignments, we are not able to distinguish much between each student's assignment. So we don't know whether they have copied, whether they have written mechanically. What we see is the correct answer. So if it is a correct answer, we are bound to give full marks. So that is not accepted because not everybody will get to the top grade or not everybody will get the same grade. So in this context, for 75% evaluation will be done through assignments and other means, other testing means. But remaining 25%, if the situation demands, there will be through a personal viva voice, where one-to-one viva voice, that is, let me make it clear, it is not for the entire 100%, it is for only the 25% just to distinguish people into various categories like A, B, and C. So if somebody has network issue, they will be called through telephone, called via telephone. So somehow we have to arrive at a conclusion. Not everybody will be getting an A grade or S grade. This time we are keeping that point in mind. Last semester the issue was sorted out because at least one exam happened, midterm happened in the institute. So yes, there was distinction between students. A, B, and C was possible. Yes, A, B, C was possible. C was the lowest grade. But this time, if everything is online, then it is more likely that we will find it difficult to distinguish who are reading and who are not reading and who are just simply copying. It is in that context, I'm saying that there will be mentally prepared that there will be a kind of viva voice with some weightage, which is not for 100%, but some weightage, just to distinguish people. And remaining things, assignments have their own weightage. If you understand and read, it is good. If you don't understand and read, it is your loss. We have nothing to do. Anyway, we are employing some mechanism to judge students properly. And there is no question of fail. It is because the assignments will cater to that particular level. So with this, I think if anybody has any queries, they can ask. With this, I think we can conclude today's class.